Jean-Philippe Bouchaud, a renowned physicist and financial researcher, has proposed a fascinating theory that challenges conventional wisdom regarding the relationship between trading volume and price impact. According to Bouchaud's approach, known as the square root law, the impact of trading volume on prices corresponds to the square root of the volume quantity. This article delves into Bouchaud's theory, explores its implications, and examines how this counterintuitive relationship affects our understanding of market dynamics. Understanding Bouchaud's square root law. The genesis of Bouchaud's theory, motivations, and background. Jean-Philippe Bouchaud's square root law emerged from his background in statistical physics and his desire to provide a more accurate model for price impact in financial markets. This section explores the motivations and influences behind Bouchaud's theory, including his work on econophysics and his collaboration with other researchers in the field. The square root law explained, unraveling the relationship. In this section, we delve into the details of Bouchaud's square root law. We explain the fundamental idea behind the theory, how it deviates from traditional assumptions about price impact, and the mathematical foundations that underpin its formulation. Through intuitive examples and visualizations, we aim to make the concept accessible to readers from various backgrounds. C. Theoretical foundations, market microstructure, and price impact models. To provide a comprehensive understanding of Bouchaud's square root law, we explore the theoretical foundations on which it is built. We discuss market microstructure theory, which examines the intricacies of order flow, liquidity, and market impact. Additionally, we explore alternative price impact models and compare them to Bouchaud's theory, highlighting the unique insights offered by the square root law. 2. Implications of the square root law. Volume interpretation, rethinking the significance of volume in price movements. This section investigates how the square root law challenges conventional interpretations of trading volume's role in price movements. We discuss how traditional views often overemphasize the significance of volume and explore how the square root law provides a more nuanced understanding of volume's impact on prices. Liquidity considerations, how the square root law impacts market liquidity. The square root law has significant implications for market liquidity. We delve into the relationship between liquidity and the square root law, examining how understanding this relationship can help market participants make more informed decisions. We also discuss the potential effects of the square root law on bid-ask spreads and transaction costs. Trading strategies, leveraging the square root law insights for decision-making. Traders and investors can benefit from incorporating the square root law into their strategies. This section explores various trading approaches that leverage insights from the square root law, such as volume-weighted average price, VWAP, strategies, and order placement techniques. We also discuss how the square root law can inform the design and implementation of algorithmic trading strategies. Risk management, incorporating volume impact with the square root law. Effective risk management requires a comprehensive understanding of market dynamics. We examine how the square root law contributes to risk management practices, including the estimation of market impact costs, the calculation of optimal trading volumes, and the management of portfolio risk in light of volume-related factors. Market impact analysis, understanding the dynamics of order execution. Order execution can have a significant impact on transaction costs and market impact. In this section, we explore how the square root law provides insights into the dynamics of order execution. We discuss the implications for market participants, including traders, brokers, and institutional investors, and highlight the importance of optimizing execution strategies based on volume considerations. 3. Empirical support and evidence. Studies validating the square root law, an overview of empirical research. This section presents an overview of empirical studies that support the square root law. We examine various research papers, experiments, and analyses conducted by scholars and practitioners in the field. By discussing the methodologies and findings of these studies, we provide readers with a sense of the empirical evidence supporting Bouchaud's theory. B. Limitations and challenges in empirical testing. While empirical evidence supports the square root law, it is essential to acknowledge the limitations and challenges in testing and validating the theory. We discuss factors that may affect the reliability and generalizability of empirical results, such as data quality, sample selection, and the influence of other market factors. Understanding these limitations helps researchers and practitioners interpret empirical findings accurately. C. Comparisons with alternative theories, assessing the explanatory power of the square root law. To evaluate the square root law's validity and significance, we compare it with alternative theories and models that attempt to explain the relationship between trading volume and price impact. By examining the strengths and weaknesses of these competing theories, we provide a broader perspective on the explanatory power and relevance of Bouchaud's square root law. 4. Criticisms and controversies. A. Alternative explanations, examining competing theories on volume impact. While the square root law has gained support, it is not without its critics. This section explores alternative explanations and competing theories that challenge Bouchaud's approach. We discuss these criticisms in detail and evaluate their implications for our understanding of price impact and market dynamics. B. Limitations and generalizability of the square root law. Despite its merits, the square root law also has limitations and may not apply universally to all market conditions and asset classes. We examine these limitations, such as the potential influence of market structure, heterogeneity across different securities, and time-varying effects, to provide a balanced assessment of the theory's scope and applicability. See practical challenges in applying the square root law in real-world scenarios. Implementing the square root law in practice poses challenges for market participants. This section explores the practical considerations and obstacles faced when applying Bouchaud's theory to real-world scenarios. We discuss data requirements, modeling assumptions, and the need for accurate calibration, while also highlighting potential avenues for overcoming these challenges. V. Practical applications and future directions. A. Potential use in algorithmic trading strategies. Algorithmic trading relies on sophisticated models and strategies. We investigate how the square root law can be incorporated into algorithmic trading frameworks, providing potential benefits for market participants. We discuss algorithmic execution techniques, market impact estimation models, and the development of intelligent trading algorithms based on the insights provided by the square root law. B. Regulatory implications and market structure reforms. The square root law's implications extend beyond trading strategies and risk management. We examine the potential regulatory implications and market structure reforms that could arise from a better understanding of volume impact on prices. This section discusses topics such as transaction taxes, market surveillance, and the role of regulators in fostering fair and efficient markets. See Future Research Directions, exploring extensions and refinements. To conclude, we explore future research directions to advance our understanding of the square root law and its broader implications. We highlight potential areas for further investigation, such as the impact of news events and information diffusion on price impact, the relationship between liquidity and volatility, and the integration of the square root law with other aspects of market dynamics. Conclusion. Jean-Philippe Bouchaud's square root law introduces a novel perspective on the relationship between trading volume and price impact. By challenging traditional assumptions, this theory highlights the complex dynamics of financial markets, while empirical evidence supports the square root law. Ongoing research and analysis are necessary to further understand its implications and refine its applications. Incorporating the square root law into trading strategies and risk management can offer valuable insights and enhance decision-making processes. By continuing to explore this unconventional relationship researchers can advance our understanding of market dynamics and contribute to the evolution of financial theory and practice.